Hello everyone, hope you all are doing well. So, welcome to your own academy, that is Rathore Science Academy, and we are here with an important chapter of CBSE 10th class science, CS chapter on your demand, that is electricity. So guys, we all are familiar with this word electricity, right? But let us try to know more about it. Say guys, we know that it is a controllable and convenient source of energy and we use it for a variety of purposes at our homes, school, colleges, industries and hospitals and so on. Even we can't think about life without electricity. That much we are habituated with it. Okay. So let us discuss in detail. There are two forms of electricity or two type of electricity. First we will discuss, that is static electricity, and second is current electricity. Now guys, static electricity, this electricity is also known as frictional electricity. Yes, frictional. Friction word you have heard in your previous classes. Why this is called frictional electricity? This static form of electricity will generate while rubbing two bodies, and we all know while we rub two bodies there is a force here, that is frictional force, right? But we are not going to discuss that. This electricity produced by rubbing two surfaces on each other, two bodies on each other, and the surface of a body accumulate with the charges, then the static form of electricity arise. Yes, we will discuss the examples also. See guys, while rubbing two bodies, there is loss or gain of electron occur, due to which the charges will produce on the surface of another body. And if we will say about example, so while we rub the balloon on the woolen cloth, right? While we rub the balloon on the woolen cloth, then we will hold it to the wall, right? It will stick to the wall. Why it happens? The reason is when we are rubbing balloon to the woolen cloth, both are at that time electrically neutral because both having equal number of protons and electrons, right? While rubbing the balloon to the cloth, the balloon will get more electron from the woolen cloth. So by the donating the electron, this woolen cloth become positively charged, and while gaining the electron, the surface of that balloon become negatively charged. That means with electron it become negatively charged, right? And that's why it will stick to the wall or can be hold with the wall, right? Second example is very good example. I remember my previous school days, even your school days, what we used to do, we used to play with plastic scale. Yes, with plastic scale. That plastic scale, while we rub on our hairs and then we will keep it up on the pieces of paper, that pieces of paper will stick on the plastic scale. Why? Because the surface of a scale also get some electrons, get some charges, due to which the pieces of paper will attract to the plastic scale, right? So this kind of electricity, the important thing we understand that this kind of electricity, static electricity, will produce while rubbing two bodies. The sharing of electron occur, or you can say not sharing, transfer of electron occur, right? The charges were produced on the surface of the another body, due to which it will stick to the wall or it will stick to the paper, right? Or paper get stuck to it. Now see, The another form, or you can say another type of electricity, is current electricity. And this is very important type of electricity, because your whole chapter is based on current electricity. Okay, let us discuss about current electricity. Current electricity developed due to flowing of charges, or you can say flowing of electron from one point of circuit to the another point of circuit. Due to the flowing of electron from one point of the circuit to the another point of circuit, or you can say steady flow of electron from one point to the another point of circuit, the current electricity will develop. Now the whole chapter, as I said, based on current electricity. So let us discuss current electricity in detail. Okay, now you will say this is important, why we discuss this. Yes, we have discussed static electricity just because sometime examples are given and you have to identify that which one type of electricity it is, whether it is current or whether it is a static or frictional form of electricity, or might be in definition it may be asked. So that's why. Now we will discuss the current electricity in detail. So before going to this, we will discuss about charges and we will recall our previous knowledge too. See guys, in previous class we have studied that every matter that means which occupy space, that is so much in detail, but matter, anything may be matter, that scale, pen, pencil, human body, that board, so all matters, right, are made up of small atoms. We have discussed that, or you can say that in previous classes we have studied that, right? So every matter is made up of atom, this kind of atoms, right? And further we have discussed that these atoms also having protons and electrons and neutrons. Protons are positively charged, electrons are negatively charged, neutrons, they are neutral, right? No charge. So with this phenomena we will go through this chapter, right? Protons positively charged, electron negatively charged. So let us discuss about charges. Charges, there are two types of charges we will discuss here, that is positive charge and negative charge, right? Positive charge on protons, negative charge on electrons, right? When two positive charges are there, or you can say two negative charges are there, right? So these are the same charges we are saying like charges, like or same charges. So same charges will repel each other. Same charges always repel each other, right? Same charges always repel each other. And if there is a positive charge and there is a negative charge, there is a positive charge, negative charge, right? That means unlike charges, or you can say charges which are not same, unlike charges, they always, what they does, unlike charges, positive, negative, they will attract each other. Unlike charges, or the charges which are not same, they will attract each other. We all know that, right? And another thing, the positive charge or charge on one proton is equal to the one 0.6 into 10 raised to the power minus 19 coulomb. Okay, and charge on one electron, negative charge, minus 1.6 into 10 raised to the power minus 19 coulomb. You have to learn it, you have to remember it. Okay, and you know, wherever I mark a star, that is important. So charge on one proton, 1.6 into 10 raised to the power minus 19 coulomb. Charge on one electron, minus 1.6 into 10 raised to the power minus 19 coulomb. Coulomb is the unit. Let's see, coulomb. Is the unit of charges. Coulomb is the SI unit of charges. Now see, then how much 1 coulomb will be? 1 coulomb will be equal to how much number of electrons? You can say, question arise, determine the number of electron present in 1 coulomb charge. Determine, charge is given 1 coulomb, and determine the number of electron in 1 coulomb charge. So as we know, electron having charge 1.6 into 10 raised to the power minus 19. 1 electron having this much of charge, right? So n number of electron, for that, what will be the formula? For that, formula will be, for n number of electron, n into E, right? Now see, we have to find out the number of electron present in 1 coulomb charge. So for that, Q is equals to Ne. This is our first formula that you have to remember. Now Q is given how much? 1 coulomb, and we have to find out N for number of electrons. E, we know that E is 1.6 into 10 raised to the power minus 19, right? Let us solve out it, and this will go beneath this. So 1 upon 1.6 into 10 raised to the power minus 19. Now see, this minus 19 will go up and convert into positive, right? So N is equals to 1 into 10 raised to the power, now plus 90. It will go up and become positive. 1.6. Now see, can we break this 10 raised to the power 19? Yes, we can. We can write it like 10 into 10 raised to the power 18, right? We can write like this, and upon 1.6. Now remove this point, it will become 100. Okay, I have removed this point and it will become 100. Now 100 upon 16, how much it will be? Calculate faster. It will be 6.25 into 10 raised to the power 18 electrons. That's what we are counting now. So that means 1 coulomb charge, 1 coulomb is equal to 6.25 into 10 raised to the power 18 electrons. Right? This you have to remember that 1 coulomb is equal to 6.25 into 10 raised to the power 18 electrons. 1 coulomb electron is equal, 1 coulomb is equal to this much number of electrons. Or you can say 1 coulomb carry this much number of electrons, 6.25 into 10 raised to the power 18. So you can learn it or you can find it out with the help of this formula, right? Now come to the next. We have discussed about charges. Let us discuss about electric current. What is electric current? What is the symbol of electric current? Yes. Electric current. Symbol is I. What is electric current? What we call electric current? The rate of flow of electron, or you can say not electron, the rate of flow of charges. The rate of flow of charges is called electric current. What I said? Rate of flow of charges is known as electric current. That means what? That means I equals to rate of that means something upon t. T is time. That something is what? Charge. Right? That something is what? Charge. A charge is denoted by Q. So I is equals to Q by T. The rate of flow of charge. The rate of flow of charge is known as electric current. I is equals to Q by T. Q. Unit of Q is, unit of charge is, we have discussed, yes, coulomb. And unit of time is second. So unit of electric current, coulomb per second, or you can write coulomb per second is known as ampere. So unit of electric current is ampere. Unit of electric current is ampere. Now see, so many times it has been asked, define 1 ampere. So 1 ampere is what? From here you can learn. If I write 1 here, so 1 ampere, from here we can find the definition. 1 ampere is equals to what? When 1 coulomb charge flowing from a point in 1 second. When 1 coulomb charge flowing from a point in 1 second, then the current is, this circuit or current in the conductor is called to be 1 ampere. I repeat, so many times this definition has been asked. So when 1 coulomb charge flowing in a conductor in 1 second, then current is known as 1 ampere. Okay. Now from this you will understand that ampere, ammeter is a device. Ammeter is a device to calculate the electric current. From this A, remember it, don't be confused. Ammeter is device which is used to measure the electric current, and Remember one more thing about ammeter. Ammeter is always connected in series in the circuit. Ammeter always connected in the series in a circuit. And symbol for ammeter is what? Symbol for ammeter is this. Okay. Now question arises, and yes, everyone want to know why ammeter is connected in series. Although series combination, parallel combination, we will discuss these two combination later on. But the reason is why ammeter connected in series, or a circuit diagram I will show how it is connected. Let us draw here. See the circuit diagram. I will draw a rough diagram. This is electric bulb where the ammeter is. Positive, negative, positive, negative. This is lamp, or you can say bulb, current I. Now see, ammeter is always connected in series in a circuit, that means in this manner. And always remember, positive side of ammeter is always connected to the positive side of battery, and negative side is always connected to the negative side of battery or cell, right? Of a ammeter, right? Ammeter is a device to measure the current. Now see, question asks why ammeter is connected in this manner in the series of a electric circuit, right? Why it is not connected in parallel like this manner in the parallel to the resistor? Why it is not connected in this form? It is wrong. It is not connected in this form. It is not connected in parallel. It is always connected in series. Why it is so? The reason is the ammeter having very low resistance. Now another name you got resistance. So this will also we will discuss in detail, but here you can know that resistance is a barrier for current. It works as a barrier for current, right? Or you can say it oppose the current. Oppose the current. Stop the current. Barrier, work as a barrier for current, right? That means if resistance is high, current will be low, because it works as a barrier for current, right? And if resistance is low, current will be high. So ammeter having very low resistance, and that's why it is connected to the series to get the total current passing through it, or you can say right quantity of current will passes through the ammeter to measure it, right? Why it is not connected parallel into the circuit? The ammeter never connected parallel to the circuit just because it having very low resistance, and if it is connected in parallel, it will draw high amount of current. That's why the chances of burning of device more. Okay, so you have to remember it is always connected in series because of its low resistance. Got it? Shall we run? Now we have discussed about charge, we have discussed about electric current, we have discussed about ammeter, why ammeter is connected to the series. Next thing, we will discuss about conductor and insulator. Conductor, this term you will listen so many times, and insulator. Conductor, which conduct the electricity, right? So conductor having more free electrons to move inside a wire. Now let us see a diagram. Suppose this is a metallic rod, right? This is a metallic rod, or not rod, metallic wire, we can say. This is a metallic wire. Inside this metallic wire, atoms are present and the small free electrons are present. Atoms and this free electron. And due to this free electron, they are randomly move inside this wire when they are not connected to any circuit or any battery or cell. When they are connected to the battery or cell, what happens? They will start flowing in one direction, right? Unidirection. So due to this electron, due to this free electron, the electricity, or you can say current, will generate, right? In case of conductor, or you can say in case of metals, copper, silver, in case of these conductor, what happens? The number of free electrons are high. Number of free electrons are more. And if the number of free electrons are more, then current will be more. Or you can say they are good conductor of electricity. Insulator. In case of insulator, no free electrons are present. Very less or no free electrons are present, and if there is no free electron, that means they are poor conductor of electricity, or they will not conduct the electricity. If we will take the example of conductor, then silver is good conductor of electricity, copper, gold. And if we will take the example of insulator, that will be plastic, wood, right? So here we understand that conductor are those materials, those metallic wires, or you can say silver, copper wires, or gold wires that can conduct the electricity, right? Now with the help of this diagram you can understand better. Suppose this is a copper wire. We have seen copper wire at our houses, right? So what happened here? Inside this wire, the wire present in our houses, inside this wire, this brown color wire, the copper wire, is known as conductor, which conduct the electricity. The electron moves inside it, right? And this cover, the black color cover, is work as insulator. The plastic wire is known as insulator, due to which we will not get the shock or current, right? You can hold it easily. Now come to the next. If you want to note it down, you can. Otherwise, at the end of video, you get whole notes, whatever we have discussed here at the end of this video. So keep watching till the end. It will be very helpful to you. Next important term is electric potential and potential difference. Question has been asked from here also. Electric potential or potential difference. To understand this, see an example. How you will able to write easily the definition of electric potential or potential difference. Let us first discuss the definition of potential difference. PD, potential difference. Suppose this is a point A, this is a point B, right? And a unit positive charge. This you have to remember, unit positive charge plus 1 coulomb. Unit 1 positive coulomb charge plus 1 coulomb charge, unit positive charge. So now we have to send this plus 1 coulomb charge, or you can say unit positive charge, from point A to point B. So there must be a force required to send this charge from here to here, right? And that force, that energy is work done. Some work we have to do to send this unit positive charge from this point A to point B, right? So from here, right now I guess you got the definition, okay? The amount of work done to send a unit positive charge from a point to another point is known as potential difference. The work done to bring a unit positive charge from a point to the another point of circuit is known as potential difference. The amount of work done to bring 1 coulomb charge, unit positive charge, from a point to another point of a circuit is known as potential difference. The symbol of potential difference, because it is a difference, we use the symbol del V. The amount of work done, so it is W to bring a unit positive charge, so W by Q. Delta V is equals to W by Q. The amount of work done to bring a unit positive charge from a point to another point of a circuit. Del V is equals to W by Q. W is work done. And unit of work done is what? Joule. Unit of charge is coulomb. So unit of potential difference is volt. Okay. The amount of work done to bring a unit positive charge from a point to another point of a circuit is known as potential difference. The unit of potential difference will be volt. And from this V, you will able to know voltmeter is a device. Voltmeter is a device to calculate the potential difference, right? And it is always connected parallel to the circuit. Okay, voltmeter is always connected parallel to the circuit, and symbol of voltmeter is like this. Got it? Now, why voltmeter is always connected parallel to the circuit? For this, we will draw a diagram. Suppose ammeter we have discussed always connected in a series, right? So I am drawing this also. That's why there will be no confusion. This is voltmeter. The diagram is a little bit tilted. You assume in proper way, okay? As I said, positive side will always be positive side. Positive side of cell will always be the positive side of ammeter, and negative side will always be the negative side of ammeter. Okay. And this is the voltmeter, which is connected parallel to this resistor or resistance. So why voltmeter is connected parallel to a circuit? The reason will be just opposite that we have discussed in ammeter, right? It is always connected parallel to the circuit because resistance of voltmeter is high. Resistance of voltmeter is very high. That's why it is connected parallel to the circuit, so that the proper amount of current can pass through it. If it is connected, if voltmeter is connected to the series, then what happen? Whenever if we do like that, which is not happen, if we connect the voltmeter to the series, then due to high resistance, and you know that resistance, if resistance is high, what will happen? Current will become low. So amount of current flowing inside the circuit will be reduced, and we are unable to get the proper amount of current in the circuit. That's why voltmeter is always connected parallel to the circuit. Got it? Ammeter always connected in the series combination, and voltmeter is always connected parallel combination in the circuit. So we have discussed about potential difference, right? Now what is electric potential? Electric potential. The same way we will learn the definition. Suppose this is point A, again this point B, but this point B somehow kept in infinity, right? So again we will do some work to bring one Coulomb charge or unit positive charge. Now in case of electric potential, the work done to bring a unit positive charge from infinity to that point, the amount of work done to bring a unit positive charge, this unit positive charge is here. So the amount of work done to bring a unit positive charge from infinity to that point is known as electric potential. Okay, the amount of work done to bring a unit positive charge from infinity to that point is known as electric potential. Okay, so V is equals to W by Q, amount of work done to bring a unit positive charge, right? Now see why electric potential or why potential differences, why we create potential difference. We understand till now that there is a metallic conductor. Here the electrons are present, small electrons are present, which are responsible for generation of current, or you can say for producing the current inside that conductor, that metallic wire, copper wire. Now if we talk about potential difference, we have discussed the amount of work done to bring a unit positive charge from a point to another point of the circuit, right? We have discussed that. That means that force which allows them to move from a point to another point, that is potential difference. And that force is we will get through battery or cell, while connect this with battery or cell, this force will produce, due to which the electrons move one point to another point. So why potential differences? To understand this, see, all things will flow from high to low. If we will talk about water, right? So water will flow from high level to low level, right? Okay, if there is a difference between two levels, air is also flow in tunnels when there is a difference of high pressure to low pressure. Only then from high to low air will flow. The same way, inside a conductor or in a circuit, electron will flow from high potential to low potential. And due to this difference, they can easily flow from one side to another side. And this potential difference that I said will generate it by battery or cell. Got it? Good. Let us move further. Till now we have discussed what? We have discussed from beginning, if we will talk, we have discussed about what is electricity, static electricity, current electricity. Then we have discussed about charges. positive and negative charges, right? Then we have discussed about conductor and insulator, we have discussed about electric current, we have discussed about electric potential and potential difference, and we have discussed, we have note the formulas also. So see, let us solve one question. If given, find out the work done to bring a 1 or you can say a 3 coulomb charge when potential difference amount, find out the work done when to bring 3 coulomb charge when potential difference is given 10 watt. Find out the work done from a point to another point when to bring that 3 coulomb charge when potential difference is given 10 watt. Solve it out, you know the formula. Potential difference del V is equals to W by Q. W is given 3 coulomb, Q is given 10. Q is given 3. W is given work done, that is not given, we have to find out, and potential difference is given to us. Potential difference is what? 10. We have to find out the value of W by 3. From here you can add the value. W is equals to 10 into 3, 30. Unit of work done, Joule. So 30 Joule work we have to do when we send 3 coulomb charge from a point to another point of a circuit when potential difference is 10 volt. In this manner you can solve out so many questions. Later on one video we will discuss about numerical only. We'll use all the formulas of this chapter and solve out so many numerical that has been asked previously.